currently which week are you at? Are you studying or anybody? Okay. What was that doing? Rajesh, you want to say something? Okay, I think we ought to be starting now. Okay. Am I clearly audible first of all? Yes. Gayatri, you have any doubt? Okay, so Gayatri, you can unmute yourself if needed. So I'm going to press that now. Are you able to see any response? Because I cannot see the chat from there, so you can unmute and speak. Are you able to see?
Yes, I'm able to see.
Okay, okay, okay. So, so the this is the week one actually, and a lot of the questions are from the actually all of the questions are from the assignment. Actually, assignment is a different one or something. The practice purpose. Achha. We can do these as well, okay? But we're doing the assignment first. The due date on 5th, 5 and 8. Achha. There is still date for it, huh? 5 and 8, no? Achha. Okay. So I cannot give all the details then because like you have to submit, you're supposed to do it yourself. I thought the date has passed. You're still to submit this assignment, right? Am I correct?
Yes.
Achha, achha. Okay. A good turnaround for second lecture, and we are getting started. Okay. So, so the question, as you see, there are two numpy arrays, and they have defined the arrays themselves. So you're not allowed to change this. Okay. First, let me connect here, and so let's keep reading while it's connecting. And so the two numpy arrays are there. What you have to do here, compute the element wise product. Okay, so what does that mean? You okay, so this is this is three three cross four matrix. Okay, let me write it down here. This is three cross four, right? Now this one is uh, so what do you say this is? Is it a four cross one or one cross four?
1 cross 4.
Okay, so this is connected now, and so this is the situation. There is one row and there are four columns. Okay, and you have to print the shape now. So let's see what it is. understanding here is different. Acha, so it's a vector. Okay. Okay, so it's like right like this. Huh? Let me check. Okay, so that is the convention. Okay, it just shows how many elements are there. Acha. Okay, so this is your reference here for any confusion. Google search. Okay. So this is done here. Now, so what they're asking for is the product. Okay, and okay, so product is done like this. Right? No AI suggestion today. Let's acha. I write it like this. Huh? Okay. Okay. So what it does basically here, write it down. But do you really need this much coding help, or like I can pass through? Let me explain some of these. If all the questions are coding questions, I cannot pass through. Okay. So what is the point here? Mm, yeah. So the thing is that so 3 cross 4 and there is 4 cross 1, right? Okay. Okay. So who answered like what is the dimension of ARR2? Too many notifications. So that person is not wrong, okay? But the thing is like, let's see who are there. Can someone say who answered like the question like what is the dimension of ARR2? There's nothing to scold in, just like discuss. No, nothing to fear. Okay. It's not wrong actually. So dimension is like whether it is a 1 cross 4 or 4 cross 1 is not defined in numpy. Okay, so when you make that product here, so it adjusts the dimension in that way. Okay, so this 3 cross 4, so this ARR2 has to be 4 cross 1 to make it 3 cross 1. Okay, so that is how it is done. Okay, because in my matrix multiplication, so where do I write it? Here, maybe here. So you have 3 cross 4, which is the first argument. Okay, and then there is another matrix, so it has to have the first dimension 4, cannot have 1. Okay, and the next dimension, because it's a 1D array, has to be 1. Okay, the multiply 4 is taken like it goes out of existence, so it becomes 3 cross 1. Okay, so you can, other than printing the shape, you can print the array itself as well. Okay, so this is it. Okay, any doubt? No doubt, right? Any
The
doubt?
final code returns 4 by 1 dimension, right?
What are you saying?
The final code, it returns 4 by 1
Final code?
results. Yeah, this code returns the 4 by 1 dimension only, right?
This one?
Yeah. See, below the output is there, right? Your code ends here. Below that, we are getting the some output, right?
Uh-huh.
It's a 4 by 1 only it returns, right?
So this is first of all 3. Okay, 3 elements is there. Okay.
Yeah, three elements only it returns, right?
But we have to understand, like, so as we were saying here, so this one is has to be like 3 dimensional. Okay, so it is there, but whether it is 3 cross 1 here, or it means like I was explaining here, whether it is 1 cross 4, or whether it has to be taken 4 cross 1, that is what I was explaining. It has to be taken 4 cross 1 for the multiplication to happen, not 1 cross 4. Do you understand
Mm,
that?
yes.
So that was the thing, because like the orientation 1 cross 4 or 4 cross 1 is same in NumPy. We have seen this reference, right? You can take a look.
Mm, okay.
Okay.
Yeah.
Okay. So moving on. Now row means is what they want, right? So you have this, okay, and you have to take a mean of this element, okay. So what is it going to be? Okay. So how are you going to do it? Is if you take like so if you do this, what are you going to get the answer? You don't know AI suggestion, what happened to AI, or my internet weak. Okay, so this is it, okay, and so so if you do this, if I print row means, what is the answer going to be? Can you guess? Sure. Okay, this is a trivial case, honestly. Uh, so let's make it a little different, okay? Otherwise, I'm not able to illustrate. Now this is 2 cross 4, right? Sure. What happened here? So this is there. How do you write it? ARR2. What am I doing wrong? Uh, can anybody point it out? Shit. the AI suggestion. Okay, okay, okay. Got it. Accept. Okay, so done now. It's going to be 2 cross 4. Okay. Do you think this is going to work now? First, let's remove this one. Yes. So it doesn't work. Do you understand why it doesn't work? Anyone? Because calculation becomes this, right? This multiplication is not possible. Clear? It's not the way, huh? Predict transpose, that should work, right? Any other way to do transpose? It's np dot transpose. There is oh shit. Transpose. Yeah. So do you understand? Predict transpose, this becomes, right? This is possible, and this becomes 3 cross 2. Any doubt? Are you able to understand? Okay. Let us vary the number. Okay. Otherwise, harder to understand. Let's have some easy numbers. Okay. 1. This is 2. This is 3. This is 4. Okay. Okay. The answer becomes this. Okay. Any doubt? Very much silent class. I have to switch between screens. So let's see who are there. Rakshita, any doubt? So who was actually answering there? It's a very less active person. Can help me in this lecture. Who was maybe not here now? I don't know. Someone can be more responsive so that I don't have to switch screens. Uh, Please. Okay. I guess I have to switch screens. So, so as you see, this is the answer. Okay. Now, if I do this, uh, okay, I have to print this as well. Okay. Okay. So, do you get what is it doing? Is it the right answer?
No, sir, I don't have any doubt.
Hmm? Saying nothing? Rakshita?
No, sir, I don't have any doubt.
You don't have any doubt. But can you answer like the
Yes.
question? Like, is it the right answer? 51.75. Should it should it be the answer to the question that is asked here? Calculate the mean of each row in the resulting product array. Is this the right one? Do you think? Have we done correctly?
Yes, sir.
Do you think so? Acha. So actually it is wrong. Okay. Let me So why is it wrong? Okay, let me explain. So the array as you see is this one, right? The scaled array. Okay. Now what you have to do, you have to print the row means like for each row you have to calculate the mean. Okay, so 30 plus 13 is how much? 43.5. You take mean of that 43.5 by 2, that is 21 point 21.75, I think. Am I doing wrong? Yeah, 21.75. So the answer should be, not able to write it, 21.75. Then what it would be is 70 plus 103.5 plus 51 and 51.75. And then there is uh, 163.5, 81.75. Okay, this should be the answer. Am I correct?
Yes, I think.
That is the correct answer, right? But you're getting a single number. What happened? It's actually taking the mean of the whole array, that is. So add all the number, then divide by number of elements there are. That is 6, right? So that is how it can achieve a single number. Okay, because it should be a this vector, right? So it is not working out. Our formula is not working out. So there is a trick, like access as a, what do you say? So for this function, you give another input to the function axis. Axis becomes 0, 1, like that. Okay. So let's try with 0 if you get the right answer. Oh, what is this? Has to be three-dimensional array vector. It is two-dimensional. Can you point out like what are we doing wrong here? It should be three-dimensional vector, right? Any idea? So let's see. Participants. Uh, Dhanalakshmi AP BME. Response. So whatever. So this is also wrong. Okay. So it is doing column wise mean. Okay. So it is taking the elements of the column, adding them, and dividing by 3, because the number of um, okay, if you do column wise, there are 3 elements, so it has to divide by 3. Okay, that is how we're getting the answer. This one is the easy one. Okay, this is like 210 by 3, so that is 70, right? We do column wise, but we need more row wise, so let's make it 1, and we get the answer. Okay, so this works out, right? If we put 2 there, let's see what happens. Oh, it is error. So only 0 and 1 values are possible, and this gives the answer. So clear? Everybody? It down. Saloni. Okay. So next thing is like we need the standard deviation of mean. Okay. So this is the mean, right? And we need the standard deviation of mean. What does that mean? Okay, how much does the number deviate from the standard deviation from the mean? Okay, so that number we have to report. How do we do that? Okay. Also, this is standard deviation of row means. That is what we need. We take the row means array, means vector, and in there we calculate the standard deviation. Okay. Standard deviation should be. Well, let's see what happens. Okay. Let's not reduce so much. Let's print as well. Sure. So how does it calculate the standard deviation? So let's see here. Anybody has any doubt? Are they getting bored? I don't want to make it boring. So this is the formula of standard deviation. So okay, here it is. And so if you do it, and you'll get the answer basically that. But so I'm not going to do that, but I'm going to explain how that happens. Okay. So what you're going to do is you're going to iterate through this numbers. Okay. And first you need the mean of these. So first of that, for that, what you do, you print the row means and np mean of that. Okay, let's see the mean. Oh, it is 51.75. Okay. Next, what you need to do is need to subtract next what you need to do, too many tabs. Let's leave the back. I think this is enough. Acha, another for your kind information, like this is my YouTube channel. This is not the YouTube channel. Let me bring the YouTube channel. And this is my YouTube channel. Okay, so I am a very avid teacher, as you can see, and there's a lot of teaching videos. And so let me share the link with you, so you'll get the recording of the sessions there as well, and also on that course page as well at the bottom. Just let me share. Okay. So let me continue. So I was just going to show how things happen here, because this is the formula we have. This is what we need. Okay. do it manually. Can we run a for loop on the numpy array? So let's see. Yeah, it suggests that we can. It's strange. Not able to print though. What we're going to do is calculate a sum here. Sum equals to 0. Okay. And how are we going to calculate the sum in a different way though? It's a normal, not normal sum. Okay. So what we're going to do is sum this up. Okay. Summation that there is. Okay. Xi minus mu square. So let's do that. So what we're going to do, sum plus equals to so there is square, right? So and p dot for square there is no much difficulty. So what I'm going to write here is xi, right? That is row means I minus what is going to come, the mean is going to come. Okay. So let's denote the mean with mean, absolute mean, capital M. Oh no, not memory error. Okay. And then square of that. This one, what do you want to add, right? Yeah. And okay. So we get the sum. Okay. And then what we do, we divide it by root of divide by n, then take a square root. Okay. So we divide by n. Sum equals to, that's the one. AI suggestions have started coming now, so I'm a lot less worried now. Okay, so you get the sum now, and so you have to divide by n. Okay, and then we take the square root. Standard deviation is this. You understand? You see? So now we're going to print this standard deviation, of course. It gives the right solution as well. Okay. So it should be 24.494 like that. Okay. Any doubt? Let's see. Or it gives error. What did I do? On this bracket problem. Too much bracket. Reduce the bracket. Still problem. Bitwise or acha. So square, acha, you can just multiply. Make your life easy. Okay. Again. You're just giving wrong suggestions then. What a shame. This one cannot be done like that. Power is there. There is. Does this work? Let's see. It does work. You get the answer. Any doubt? So what it is asking for, is it clear? It is not standard deviation with respect to of this scaled ARR with respect to row means. It is not that. Standard deviation in that row mean of that row mean vector. Okay. And I have done the manual calculation as well without using formula. So AI, you see, does mistake. Too much dependence in AI can be a problem. Any doubt? Soman Bhattacharya. That's a new name. No answer though. Okay. Let's continue. Okay, you get the answer. You can have the original array and calculate it yourself. Formulas remain almost the same except this one. I shouldn't say that much as well. You should be able to figure out yourself. Acha, because you have changed the array, you cannot choose those. You can do it yourself, I'm not going to say everything, of course. So next is eigenvectors and eigenvalues. Okay. Anybody feeling bored or something, like need something interesting? Too much implementation, no fun. No response. Honestly, I'm getting a little bored. That's what I thought. Ashwini, are you getting bored? You have just entered. So some old participant means Rajesh Kumar. Are you getting bored with this implementation business?
No, no, not at another one. But can you please show me that like how to implement it, that questions, right? Just we need to go through the implementation part also parallelly.
So this is the implementation part. What more is needed?
No, so we have to fill the like we are getting the questions like fill in the blanks kind of thing, or like we need to write the code over there.
Acha, let's see. I don't know myself. Let's see. So this is like options are there. Like, okay.
Okay.
So you just select the
Or
option.
manually we need to calculate for
No,
it,
you
right?
don't need to manually calculate. You have to use this program.
Okay, they will provide the editor also to us.
No. This is for this assignment. You have to.
Assignments, right? No, in end exam, they will provide the like this one notebook, or how we can.
There will be no such question. Nothing to worry.
Okay, okay.
Okay, but are you like enjoying this or is it too boring?
No, I am enjoying.
Enjoying. Acha. Good to know. Okay. But I honestly got a little bored. So let me take a break, 5 minutes break, okay? And then I will explain some theory, okay? So that we can, because this is not computer vision, of course, and okay, and learn some computer vision, okay? And maybe do some this type of questions as well, like this type,
Sure.
okay? Just 2 3 minutes. people are here. Uh, so we did some code implementation, which was honestly very boring. Uh, so I want to go to some theory and explain some of those. Okay. Uh, okay. So lecture slides are there. Okay, that's an interesting start. So let me start my iPad. Okay, I will do it there. Where do? Just a minute. What we're looking for? Google Meet. Sure. Okay. So we able to hear?
Yes.
Okay. So what was I telling here? We go to the so there are a lot of lecture notes here. Which one should we go to? I think part 4 is interesting. Let's go there. So right entry, okay. So let's understand some computer vision to break the implementation monotony. Okay. So uh, so the invisible light spectrum. I'm not able to edit. So let me download. Okay. I download things.
Sorry to interrupt. We are not able to see your that
Okay. Okay.
screen.
Okay. Let me fix that. Hmm. So this is done now. This is the one. This is previous week. This is downloaded or could not download. Let's try again. In the meantime, let's. So what are they going to do? So I could not download. Okay, bad day for us. Nothing we can do. Uh, so what was I trying to do here? Sure. Screen presentation should be better. Acha. Just a minute, okay. Let me fix because the recording needs to be good as well, right? Okay. Full screen, and then can I fix this as well? I think this is okay. Okay, so we'll have to manage with whatever we have. Okay. And now the visible light spectrum is very pure. You know that why RGB color representation because there's a base color. Okay. Uh, So, but they explain it much better way. Okay. Uh, so there are basically they explain that there are four chromosomes. I have four cones. I think. Humans have whatever. Okay. Okay. So image we represent as a matrix from values 0 to 255. Okay. Okay. So that is one as well. Image as a function from r square to r. Okay. So r square is like the input dimension. So input is a two dimensional image, right? So that is there, and the output is a scalar. Okay, so it's a grayscale image. Okay, if it was like suppose RGB, so it would be R cube. Okay, so that is done as well. So image from
Hello, sir.
okay,
Hello.
yes,
Sorry to interrupt you, sir. Sir, that not understood, sir. Like F R square R.
okay, this one, no? So
Yes, sir.
image is a two-dimensional object. So there are two dimensions. One is length and then one is breadth. Okay,
Yes.
and
So F of x comma y we have displayed there, and what is the R square for?
that is the dimension it represents. Okay, two dimensions r square.
Okay, and why they are mentioning again R, sir, for like
R
indicating?
is the value. Okay, so each pixel has a value, right? If it is a grayscale image, so it is like black and white. Okay, if it is so if it is 0, it is black. If it is like 255, it is white. Okay, anything is between,
Hmm.
anything in between is a of some
Yeah,
color.
shades of black and white.
Yes.
Yeah, shades of black and white.
So but as you know, colorful images have three channels. Okay, so that would render it r cube. Okay, output is r cube. So what does that mean? R is some values, G is some value, and B is some value. Okay, so it can be like the problem is not able to edit here. I would write here. Maybe there is some other way. Uh, let's try this. Maybe it will work out. Never know. Let's see if I can.
So you are telling that R square is for grayscale we have taken, and R cube we can take for the
No, no, no.
color.
The input will
Hmm.
always be r square. Okay, but the output is r or r cube. If it is grayscale image, it is r. If it is like colorful image, it is r cube. Okay.
Okay.
Let's see if now it will work.
So for black and white and grayscale, both will be R. It will be R.
Yeah. So I think it worked out somehow. So as I was here, okay. So am I able to write? I'm able to write, but only one color. There's no fun. Uh, no more color. A color change I can do from it. So, okay. So it's gonna be. So so if it is like a 2D image, it's like 0 1 place and then 255 somewhere else. Okay, so there's bright spot, there's 100 somewhere, and like that. Okay, and suppose it is like RGB. So R values are first of all given 0 100 200. Then beneath it, okay, lies G, so that it can be 100 20 50 like that. Beneath it is blue, it can be something else. Okay, so uh, so they're taking it as a continuous function. Okay, but 99.99% of the situation you have to encounter a digital image which is a sampled and quantized version. Okay, so these are discrete versions, right? There's a big
Sir,
difference.
one more small doubt, sir. Like normally we are considering that we are representing image as a format of f of x comma y.
Yes.
But what if that image is a 4D or like next, like around 9D and all something are coming? I'm not much aware about it.
It is not an
But
image.
how it is not an image, sir? Like normally we'll say like a 4D something like 4D or 3D or something. 3D also we can say, na, sir. In 3D, how it will be?
3D is not an image. It's called voxel. Okay. So R cube to R whatever be this one. Okay. In case of voxels, and that is the maximum. You can represent a full space using R cube. You can take a time as well. So R cube comma time. Like that's with time how the space is changing. Okay, but these are not images.
Oh,
Okay,
okay, okay, sir.
image if it is image it is stored it is always R square. Okay, this one you cannot change. This can be R, R square, R cube, R k, whatever. Okay.
Okay.
So let's see. So some transformation they've increased the intensity. So that's simple enough. They've written it as well. Image transformation. So they are making some the x coordinate values. Acha, they are doing a mirror image. Okay. So on this, okay. So along this values becomes negative. This value become positive. No, 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 no. What am I saying? Okay, they're transferring the pixels actually from here to here. Okay, interchanging the pixel along this axis, like against this axis. Okay, understood? Clear? So image processing operations. There are a few operations: point operations, local operations, global operations. So this is again getting boring. Okay, so let's go back to implementation. Uh, we will catch up on this later. Okay. So how do I stop presenting this one? Okay, why is it so black? Okay, so are you able to see the coding screen? How many people? 17 people. Okay, number increasing. So other people don't think that it is that boring. Okay, so let's do some coding again. So these initial lectures are so boring. Okay, but let's try to endure them. So we need the eigenvector and eigenvalues using NumPy library, then find out the largest eigenvalue and corresponding eigenvector. Acha. So even though I can just use the formula, but I'm a good teacher and I'm not just going to use the formula. Okay, so I'm going to explain what is eigenvalues and what is eigenvectors. Okay, so we go back to the iPad. It was premature to stop presenting. Okay, so let's go back to the iPad. And let me explain eigenvalues and eigenvector. For that we need a slide as well. So let's go here. I should have a new presentation as well. So let's go here. Uh, how do I change this one? Uh, okay. So given this matrix, okay, and we're going to of course select simple values. Okay. If someone asks you what is what is its eigenvalue and what is its eigenvector. uh, what do you make of it? Okay, does anybody have an idea what is eigenvalue and what is eigenvector?
I think it is used for the measures, sir. Like eigenvalues will give the how much variation is there in the data, and eigenvectors will give the in which direction that variations are there. I think so, sir. I'm not much sure.
That is incorrect. Okay, but let me explain what it is. Okay. So this is a matrix, right? And the hypothesis is that you can decompose this matrix uh, in the form of and something like this. Okay. So what is this? This is called the eigenvector, and this is the transpose of the eigenvector. Okay, and sure. Okay, so I hope I'm not doing it wrong. Yeah, I think this is the one. Okay, and this is called the eigenvector. Okay, v, and lambda is the eigenvalue. Eigenvalue is a scalar. Okay, and you can write it something like this. Okay, now the so how to calculate that is AV equals to lambda v. Okay, uh, so A is the matrix. So you calculate this. Okay, so how do you do that? A minus lambda I. Okay, and then you multiply v, that is equals to 0, right? And now the always the theory is that the this is a normalized vector. Okay, the okay, okay. To calculate the eigenvalue, what we do, put this to 0. Matrix, this matrix. Okay, if I have to calculate this, put this to 0. 1 minus lambda, lambda square minus 1, minus 2 minus lambda 0 plus 3, 1 plus 0. So what we get here is lambda square minus 1, right? So 1, if I multiply lambda square minus 1 minus lambda cube plus lambda plus 2 lambda. The equation might be too difficult to solve. I told easy values, they didn't turn out to be easy. So this is a cubic. There are three what do you say eigenvalues. Okay, too hard to calculate. Okay, but let's say they are lambda 1, lambda 1, lambda 2, lambda 3. Okay, these are the values. Okay, now sure. Now what was the thing? Okay, this is how you calculate. Okay, and then from that you can calculate the eigenvectors as well. Okay, so how do you do that is but need an easier example actually. What should be the example? Let's think through. So I want to keep one here, and then I should have yeah. So when I multiply, it's going to be this, and then there is something. I want a lambda square minus 1 equals to 0. So for that I need 1 1 minus 1 equals to 0, right? So 1 1, let's say something like this. I think this one works out. So if I do this, okay, like before, so this becomes doesn't become lambda square. That is, this is also 0, this is also 0. This one works out, okay. So this becomes minus lambda. This is minus lambda as well. This is 0 0. This is 0 0, and this is 1 and 1. It becomes 1 minus lambda. This becomes lambda square minus 1 goes to 0. So eigenvalues are, one is 1, another is 1 and minus 1. So they are repeated values. So lambda is equals to 1 and minus 1. Okay. Now these are the eigenvalues. Okay. And for eigenvectors, what we're going to do is okay, I don't know the vector xyz. Okay. Now av equals to lambda v. Okay. Now this is xyz is equals to lambda, say 1 xyz. Okay. So do something wrong. Sure. So what we do here, then x is equals to x, which is obvious, and then z is equals to y. Okay, not obvious, and then becomes y is equals to z. Okay, so x is equals to x means this is x. Okay, these are same. Okay, so we can write it like this. Okay, so okay, now okay, so what does that mean actually? Okay, so if we consider x to be 1 and y to be 1, so this becomes 1. Okay, and so this satisfies this eigenvector, that 1 1 1 divided by root 3, because it needs to have the magnitude 1. Okay, so this is one eigenvector. Okay, this is the way, right? Can I have two variable in the answer? I think the answer was like has to be one variable. Let me check. Acha. So the thing is that we need to find this, no, not this one like this, okay? So as you can see, there are two independent variable x and y here, okay? And in this situation, what happens is that we take the space comprising of the two basis vectors. So this is 1, these are 0, and this is 0, this is 1. Okay, so what does that mean is that basis vectors are with this has to be divided by root 2 as well. Okay, these are these vectors which define a space which have a magnitude. These vectors have a magnitude 1. Okay, and this space denotes the eigenvector actually. Okay, it is complicated. It got complicated. I should have some examples which were simple enough, but I thought this was simple enough too, but it got complicated. Okay, so if we do it from -1, that is a simple one. Okay, so if we do from -1, right? How do we do from -1? Equal to -1 there. Okay, and then x is equals to minus x. Okay, so this comes equals to this. The 2x equals to 0. So x equals to 0. Okay, next this is like z equals to minus y, and then y equals to minus z, so that so these are equal, right? So this becomes 0 y y. Okay, so the basis vector becomes this one. So this one is simple enough, right? Just one vector, but in that case it is the span of that two vectors. Okay, okay. So this is like for understanding what is a eigenvector and eigenvalues. Okay, and we can get back to our problem here, the coding assignment. Okay, so coding assignment here. So they need the eigenvalues and eigenvectors here. They have this. I could have taken this example, but I don't think so. This must be a good example, or may not be as well, right? They're needing it done by computer. Okay. So so if you do it by this code, it is very simple as well as boring as well, because you don't learn anything. Uh, so let me write the code here. So this is np dot largest eigenvalue. Ah. No support here. No. How do you write it actually? Does this work? No AI support here. Maybe I should refresh and then. I need to play these again. Uh, so this is done. This is done. This is done. This is done. Error. Sha. So it got really refreshed and everything is done. Gone now. Okay. With all this. Okay. eigenvalues and vectors. Now you print that. So as you can see, so for this eigenvalue, this is the eigenvector, this row. For this one, this is the eigenvector. Okay. So this is the situation. Okay. Now the other things are there as well. We'll have to basically look at the formulas on how to do this. Okay. Because if I write everything and do everything, then how are you going to do anything on yourself really? So you have to take the largest eigenvalue, find the largest eigenvalue. You can look it from here, but you need a formula. Don't need a formula. Just take max here. Okay, so that is done as well. Largest eigenvector. Okay, now what does that even mean? Vector is acha. So largest eigenvector is not the, you don't take the magnitude of the eigenvector. Eigenvector always has a magnitude of 1. Okay, so largest eigenvector means the vector corresponding to the largest eigenvalue. So this is the last one. Yeah, this row. Okay, max eigenvalue index, that is 2, right? If starts from 0. Okay, so very easy, right? Given a function definition, implement is used to apply. Acha. So these are there. Okay, let us take a small break. Okay, we'll do computer vision again, then go back to this. Okay. welcome back everyone. So let's see how many people are there. Okay, attendance is full. Okay, people are super interested in the course. Wow. Uh, okay. So not going to delay the proceedings. Okay. So I'm proceeding. I'm presenting here. Let's go back to the slide. Okay. Slide. So where is slide? Slide is here. And let me and we go where we do go presentation. Okay. So something more on the so as we have seen here, as lambda equals to 1 was repeated twice and minus 1 only one time. Are you able to hear what I'm saying? Are you able to see? Okay, very nice. Okay, so this was repeated twice, and for one, for eigenvalue 1 we got a space, 2D space. Okay, it was a span of these two vectors, right? So what was those vectors? This and this. Acha. So this was okay, span of this. Okay, so that's not too very hard to understand. So it is this vector x, one point here. Okay, and these are 0, and then y and z on the top. Okay, so this is that vector. Okay, out of the screen like that. You cannot see that. So this is x, this is y, this is z. Z is coming from the top, so let's say like that. Okay, on the yz plane there is a vector. Okay, the that vector and this vector. Okay, they will be in a plane, 2D plane. Okay, and that is this plane. This eigenvector corresponds to. Okay, and for the minus 1 case the eigenvector was, this was the eigenvector, right? And because the magnitude needs to be 1, so okay. Now what does that mean? Okay, so together these three vectors define a 3D space. Okay, and how much how much the okay, so let me explain. So these 3D vectors, with three vectors are the, what do you say, basis vector for that space. Okay, and what does that mean is that uh, this what does that mean is these vectors only you can increase the magnitude. Okay, or decrease the magnitude, or you can flip them, you can make them negative. Okay, like this. Okay, or okay, these operations are possible, but you cannot rotate them. Okay, okay, so these are rotationally invariant. Okay, and the basic thing is that these are also basis vector for the column vectors of the original matrix, or any vector in that space. Okay, so if we call this v1, v2, v3, so then the column vectors of the matrix that we have seen, we take any column. Okay, column vector, this can be represented as a linear combination of the as a linear combination of these, but this is the definition of a basis vector, which is always valid, of course. Like these three defined in the space, other vector can be written as a linear combination of these three. Okay, but the important thing is this is not just a general basis vector. These vectors or a matrix defined by these vectors cannot rotate this. Okay, but we'll try to rotate it. Okay, we are like Ziddi people. Okay, so how do I try to rotate it? Okay, so we need the rotation matrix for 3D. So okay, so rotation happens along axis, right? So upon x-axis, y-axis, z-axis, like that. Okay, and I want, so for rotation along x-axis, okay, the matrix that is 1 0 0 0 0 cos theta minus sin theta cos theta. So rotation means multiplying this rotation matrix with this matrix, and it should remain the same, right? So that is the hypothesis. Let's see what happens. So matrix multiplication 1 0 0 1 is left. Okay. Oh God, what do I write? Let me write it here. Okay. This becomes 1, and this becomes 0, right? This becomes 0. This becomes 0. Right? Yeah. This becomes cos theta plus sin theta. So that's not going according to plan. Okay. Okay, but whatever it is, we write it down. If we have done a mistake, we will figure it out. So what are you doing here? Up to this point, it was correct. Matrix multiplication, right? So this one is done. This is cos theta plus sin theta, right? And then it is cos theta minus sin theta. So this one is also not 0. Next, so it did not become what I thought. Okay, so I think more clarity is needed. I will come back with it next next lecture. Okay, or what is the thing? Acha, acha. If I perform a 2D rotation, okay, like I was doing, eigenvectors will rotate. Acha. If it is only a linear transformation, the eigenvalue's direction does not change. Acha. Okay, we learned something today. Yeah. In case of like 2D rotation, okay. Uh, so linear transformation is defined this way, that this holds, and so what does this mean is vector addition and scalar multiplication is preserved. Okay, so if you do this transformation, okay, then that eigenvector will not change. Okay, means will change, but the direction will not change. Okay, the magnitude can change. Okay, so that is the thing. But if you do a proper rotation like this, there are no eigenvectors. Okay, it will always change. Okay, which is a very crazy information for me as well. Okay, that is why we teach difficult things, because we get to learn ourselves as well. Okay, so what did we learn here? For linear transformation, the theory holds that the eigenvector does not change its direction. Okay, but if the transformation is a rotation matrix, as I was applying, okay, so sure. Whatever. Okay, let's see. We'll see this next class. I don't think it's done completely now. Okay, so what do I do now? We go back to coding. Okay, how much time is left? Some time is left. Okay. So what is going to do? Change the presentation. Now what should I do is here it is. So this is like the function we have to write, which is the our sigmoid one, which is kind of boring now. Good thing that AI helps, otherwise I'll be too bored. Defines a new list. Do we need a new list? Let's see. So what does it ask? Define a function, implement numpy and apply it on a list and perform operation. So this is a list, right? Input list. Okay, so that works. We have defined the function here, and so you cannot use this one here. Okay, so that would make it integer. You don't need that. And apply function to that list. Okay, so this will work out. Okay, so this is the modified list, right? So let's define it like modified list. Okay, let's delete this one. Some modified, some of the values of the modified list. So that's not very hard as well. Just write some and modified. There's no suggestion. Makes me write full. Okay, what can we do really? Finally, it's suggestion. I'm going to print as well. Sure, print is here. We have already done this on the previous one. It makes me do it again. This is the answer. Okay. Boring. Okay, so question number 4. Given a RGB image into GBR image by swapping the channels. Sure. So, so as we know, in RGB there are three channels, right? So you have to like extract every channel. Okay, that's the thing. That is what we have to do. So let me do that. We already seen that RGB. So channel information is the last information in the image. Okay. So they've got already an image from here. Okay. So we don't need to worry about that. Okay, it's not working. Okay. Uh, let's see. Asha, here it is. So let me download this one first and then upload here. Sure. Then upload. Upload. How do I do that? Achha, here it is. Uh, let's see. Let's go there. Is it downloaded? It's not downloaded. Okay. That's the picture. Why do always people use golden retriever for AI examples? I actually used a golden retriever for a presentation on generative models. So this sample data. So we need to upload another one here. Golden retriever. Let's buy this. Does this work? Or we have to define it another way. This does work, okay. Shape of the image. This is the shape of the image. As you can see the channel information is at last. So how do we define here image 1 and this, okay. That's the red channel, okay. Image 1 and this has to be right, right, and well, there are 2 BM IMG, okay. I think the autocorrect one. IMG new, what does it new mean here? Acha, you have to swap those, okay. So green comes first, okay. Acha, it knows everything and I agree with it, okay. New shape. uh, can you write like, you have to print the shape, right? You cannot like do like this. Can you do that? It does work, okay. So plot the image, get the image, okay. I am show, okay. So that's a beautiful work, right? It's a good illustration of what happens, okay. So they have what they have done. They have swapped the red values with green, okay. So if we just figure out, this is like quite close to red, right? So this should become greenish, right? Something like that, and green, there's so much green here, okay. So which is the second channel has been swapped with RGB. So blue is there. So is there bluish type? No. To understand the swap better. Okay, so RGB is there, right? RGB is there, GBR is there. So there is, how is the swap going on? Well, they would also, the number will also combine, understand that, right? So the addition, when the overlap happens, okay, so that would render some other color. I don't think it's very easy to guess actually. So this is question number 5 here now. Okay, apply mean filter. Okay, but we have not seen what is mean.
Sir,
Okay.
uh, s- sir, sorry to interrupt. Sir, can you explain question number four again?
4. This is 4, right?
Yes, sir. Yes, sir.
This is this image which has this dimension. The first channel is always R, then G, then B. Okay, so we loaded the image from here. Okay, and then we check the dimension. We extract each channel. Okay, so each becomes grayscale. Okay,
Sir, how to import an image?
here it is.
Yes. If it is not present and it is showing error, that image doesn't exist.
Then you have to import the image here. We got it. We're using this one. First download it, then import it here, then upload it here.
So then also it is showing error.
Can you present? Then I can check. Are you presenting?
Sir, actually I have submitted the assignment. Yes, sir. Oh, it is not.
Okay. So I can have no idea. Uh,
Yes, sir. Thank you, sir.
okay. So it is a great visual example, honestly. Not bad. So there is a library called Sky Image from internet gets from data and human mitosis loads another image from the internet. Nothing to worry about. Okay. It's downloading the file. It has done already. Okay. Then print the shape of the image. This is the image. It's a grayscale image. Okay. It brought the grayscale image. It looks like whatever. So we apply mean filter to it. Okay. So what does it do? It takes the mean around a kernel. Okay. Filter size is 5.5 cross 5. It is the kernel. Okay. If you don't understand what I'm saying, uh, then we have to see what I'm saying. Okay. So what I do now, I stop presenting here and go to the tablet that we have. Oh, people are not getting tired really. I'm getting tired though. Okay, some stamina in students. Okay. So we go back to the presentation. So let's go to the filter, skip the whatever that is. Where are the filters? Uh, oh, we got it. So these are the filters we're applying. So it's a large. Is the 3 cross 3 filter they are using, as you can see. So this is a filter. Okay, and they are averaging over that filter. So that is what we need to do as well. Okay, and we go to the mean filter. Okay, so where is mean here? Presentation खत्म हो गया. Okay, so we go to back again here, and where is this? We go here, we go there. Okay, and the lecture slides. Lecture slides are very well compiled in this course. Okay, it is difficult in other courses, just for a kind of information. Okay. So I think this one will have the filter information. Okay, linear filter. We go to probably कहाँ गया main filter. such average filter, and that is what means. Actually, it takes mean of that, right? So that is it. Okay, that is what we need. So it's doing some sort of averaging. Okay, so mean filter. So this is it. Simple enough, I guess. Just add them and divide by the filter size. Basically, divide by 9 in this case. Okay. So if you can see this block in the image, you cannot. Okay. So there are you can see 690. So 6 into 90 by total 9. Okay. So the answer should be 60. Uh, 690. Yeah, I think it should be. It would come in this position, right? So that is this one. Okay. Yeah. That is not written here. Okay. I think you got the idea. It's basically that. Okay. It's very boring, honestly. But we do the questions, right? Okay. So let me do it, and let me present again. This filter you have to apply to this mitosis. So mitosis is a biological thing actually. I think cell division process is called mitosis. That is all I know. So what I need to do now is show you the code, right? Okay. So let me do that. So we need to average. So we need to define a filter first. Okay. Or like kernel. Okay. So this is np dot once. Should it be 25 here? Cha. It has to be divided by 5, right? Because 5 cross 5, 25. So mean has to be like divided by 25. Okay, we got that one now. No suggestions. We take it from the import. There is no help on the import as well. They don't help you at all. Okay, so what is the convolution? So let's need to import something here. Try to give it some functions. Convol image to kernel, and this should do it. ऐसे तो convol काम नहीं करेगा. What is the import? What is the library?
Can one do numpy dot product in one of the problems earlier? We do dot product.
Do dot product. Well, you can do
Means
that, yeah.
and we have to
But I'm not
also
sure
not
how
use
to.
padding.
We cannot use padding. Okay, so padding is false. I think that was right. But what is the library here? What is building? Okay. Let's search. I don't need the email. Okay, sci-fi. How to use it? Okay. Signal. Okay. Can I import signal? Have the that were worked out. And we have this one, and what do you say, padding? Is the padding here? Padding information here. Mode equals to full size of the output. Sure. So let's see what the result is. Not worry too much. Print the shape of the image. Shape is not good enough. Sure. We say so that I'll do it. Okay. Shape of the image. Let's print the shape of the image. Output image. Shape should remain the same, right? If it is not, then there's problem. No suggestion, no nothing. Okay. Shape.
Shape may change if we avoid padding, because of size 2 by 2 we need to start a little inside.
What was the previous shape? 512 and it's
Yeah.
516. Sure. Sure. So what is this thing? Shape should not change or should change?
As per my understanding, I thought that shape should probably decrease maybe.
There was the formula.
Output image size after convolution.
So that's the one. Image size 512, I think.
Yeah.
And F is the kernel size. That's like 510, 517.
5.
No padding. S is the stride is 1. So how much? 517.
508.
518.
Yeah.
512 is chart. What was that?
F is 5, right?
Right, yeah. So 512, it becomes 510, 57, right? 57, 56, 57, 58 it becomes. Okay. But you're not getting that here, right?
Yeah, I
So,
think we have to start at the index maybe 2, 2 or something like that, so that the kernel is inside the image.
I do understand what you're saying. But it is trying to have, so you'll try zero padding, right? So is it zero padding? Mode, I think to define a mode here. Size of the output. String indicating the size of the output. Full valid same. No reliable full valid. Full discrete linear convolution of the input default. To not real. I think you have to write same or something. I think that will work out. Keeps it same. We'll get to the details later on. It's going to be too tired. What do they want? Okay, I cannot skip like that.
So I tried using ND image. In deep learning coursework, they have given one markdown, like one notebook. Maybe I can share the link in the chat. I also got Python, but it was using library.
Wait. What is dimension after applying this filter? Okay, what is the default? Let's understand that one. We just apply this filter. The dimension is this. Okay, so what will happen if we, so without padding, padding is important so that we could apply the filter without any problem, but they don't define whether you use padding or no padding. Okay. Okay, so what do they want actually? Let's guess that. Okay. I think the answer should be 508, right? That is what they want. How do you produce 508? That's the question. Without padding, if they have not written padding, then it's zero padding, right? The answer should be 0. Means that you cannot apply the kernel to the side values, okay? Basically that. But it has to be some function to make it happen really. It's going to be 508, of course. The answer is going to be 508. But how do you achieve that, okay? So let's see, maybe just randomly try something and it will work out. Acha, boundary is there. Okay, oh, this is the one, okay. Yeah. Default is 0. Why is it not working then? Mm, symmetrical boundary condition, fill value.
So fill value is what
Acha,
adding values to fill, I think.
okay. Acha. And not just ignore it, what the problem is. Okay. Uh, boundary, just don't do it, something. For there's something I don't know why my brain is not working honestly. So basically the answer should be 508, but I don't know exact function to make it happen. So maybe that is something you can do. You can find it out. Okay. Uh, that is all I can do really. Honestly. Anyway, it is not my work to finish the assignment perfectly. You can do something yourself. Okay. Okay, I'm done actually. Any doubt?
I just want to access the list of problems that were shared.
So that is in the
Excel sheet?
no course page, practice page.
Okay,
This one.
not these. Okay,
These are the ones.
okay.
Okay.
Yeah, right.
Any doubt? Okay, so this is done. I think it's super boring. At least I got really bored. Hope we can discuss something more interesting on the next lecture. Okay, thank you very much.